I welcome you all for my mathematics session. Let me continue with doing problems in Fourier series. This is the problem that is given to us. In this problem, I'll introduce a new idea which will be explained as and when I come to the situation. Now here you see that we will just find out the Fourier series for the function f of x is equal to x squared, which is defined in the interval minus pi to plus pi. As I have already explained in my earlier classes, that whenever you come across a function defined in minus pi to plus pi or minus L to plus L, a general interval, you try to examine whether the given function is odd or even, and then decide whether any of the Fourier coefficients could be dropped, in the sense that the Fourier coefficients will become 0 according as the function f of x is odd or even. So with this small introduction, let me come to the problem and explain the things again wherever it is required. Okay. Now, say we are given f of x is equal to x squared. X is a member of minus pi to plus pi. So this is the other way of writing is 0 less than x minus pi less than x less than pi. That means x will take all the values in between minus pi and plus pi except minus pi and the extreme points. It will not take the extreme points, but all other points in between it will take. So this is an open interval. Actually this is an open interval. Small things I am explaining so that when you read when you go through the problems, you will not find it difficult to understand. That's what every bit of information I am giving. Now, so this is what is given. Now, as I told you, first check whether f of x is odd or even. We check whether f of x is odd or even. Now, what is the check? F of x is equal to x squared. Therefore, f of minus x will be minus x whole square, which is also equals x squared, which means that f of x is equal to f of minus x for x belonging to minus pi to plus pi. This implies that f of x is even. So the first thing that we have determined that this is an even function. So we have proved that this f of x is an even function. When it is an even function, see why we do this is that in order to lessen our labor of finding the Fourier coefficients. See, I'll write here. So I have found that f of x is an even function. Now let me write the given series. Now this is given to you. The next step is the Fourier series. See, the Fourier series is the Fs. The Fs of f of x is x squared is x squared f of x is equal to a naught by 2 plus sigma of 1 to infinity of cos nx plus 1 to infinity of bn sin nx, and a naught is equal to 1 by pi minus pi 2 plus pi f of x dx. an is equal to 1 by pi minus pi 2 plus pi f of x cos nx dx. bn is equal to 1 by pi minus pi 2 plus pi f of x sin nx dx. So I have written the Fourier series, so they call this as your one. So I have written the Fourier series. Now f of x is even. See, I'll write here. So f of x is an even function. Now let us start doing this. If, see, these integrals, if this is an even function, see, I'll write here, see, note that minus a to plus a f of x dx is equal to 2 0 to a f of x dx. If f of x is, I will write it, put it in this form so that you will understand better. Let me put it in this way. Minus a to plus a f of x dx will be equal to 2 times of 0 to a f of x dx if f of x even, and is equal to 0 if f of x is odd. Now this is what I have written here. So here, what is that I have written here? Minus a to plus a f of x dx will be equal to 2 times of f of x dx, provided this f of x is an even function and is equal to this one. Now let me start check. I will go for a check here. See, what is this? F of x is even, so I can put it in this form. Now this is an even function. Cos nx, cos x is always an even function. Cos of minus x is equal to cos x, so cos x is an even function. Therefore these two are even function, and therefore I can take 2 0 to a form. So I can apply this. Coming to this, this is even, but sin nx is an odd function, because sin of minus x is minus sin x. Therefore this is an odd function. Cos x is even. See, I'll write here, cos x is an even function, sin x is an odd function. So you see that sin x is an odd function, so odd into even will be odd, so this will be an odd function. Therefore this bn will become 0. As per this I have written here, this bn will become 0, a naught will not become 0, an will not become 0, and therefore this will become 0. So this will go off. Only you have to find the value of a naught and an. Now let us so I will make things in a short, in a very short form. I will tell you that we have found this f of x is an even function. These are your Fourier coefficients, and I have written something here. If it is minus a to plus a f of x dx, if it is even, this is the result. If it is odd, it is 0. Now here f of x is even, therefore you can apply this. This is an, which is so much, which is an even function. This is an even function, so you can apply this. Whereas this f of x into sin nx is odd, therefore it will result to be 0. So this will be 0. So bn will be equal to what? Therefore, your Bn will be equal to 0. Now we have to find only A0, An and Bn. So are you clear with this, what I am talking here? Now let us start finding this one. Okay? Now let us start doing this. So now let me find what is my A0. What is your A0 now? A0. See, what is your A0? A0 is equal to, I will write here, it is 1 by pi minus pi to plus pi. It is x squared dx. As I told you, this is an even function. Therefore, 2 divided by pi 0 to pi x squared dx. So this will be equal to 2 divided by pi x cubed by 3, and this is 0 to pi, and therefore this is equal to, it is 2 by 3. Here you see that this will be equal to your pi square, because x is equal to 0 means goes off. So it is pi cubed, and you get what? Your A0 is equal to 2 by 3 pi square. So this is my first result. This is your call your first result like this. Then what is your An now? An is equal to 1 by pi minus pi to plus pi x squared cos nx dx. So this is equal. So you see that again, this is an even function, this is an even function. Therefore I can write this as 2 by pi 0 to pi x squared cos nx dx. So I'll write here. Now I apply Bernoulli's method. How to apply this Bernoulli's method? Again, for the students who are viewing this class for the first time, or otherwise also, I will write so that you will understand better the subject. Therefore I will write this, I will write in detail. That is 2 by pi 0 to pi x squared d of sine nx divided by n. See, what is this? Now you take the differential. D of sine nx is cos nx into n, but n and n will go off, giving you what? Cos of nx dx. So there is no harm in writing in this, so that I will identify this as my v1 and this is my u. Now apply Bernoulli's method. What is your Bernoulli's method now? So this is equal to u v1, that is x squared sine nx divided by n minus, differentiate this and find the integral of this. What is the integral of sine nx? It is minus cos nx divided by n, but already that one n is there, the x squared, then plus differentiation of 2x is 2, and the differentiation of integration of cos nx is sin nx, so it is minus is there, so sin nx divided by n cube. Everything must be raised to limit 0 to pi. I have, see, you go through my earlier videos, I have explained in detail everything, that when you substitute for x here, sin n pi is 0. That is, sin n pi for all values of n, it is equal to 0. See, here I will write here. See, I will just explain this. Sin n pi is equal to 0 for all n. Cos n pi is equal to minus n to the power of n. That means when you put n is equal to 1, cos pi is minus 1. When you put n is equal to 2, it is cos 2 pi, it is minus 1 whole squared, it is 1. So you see that this cos n pi will take the value -1 plus 1 minus 1 plus 1. That is, for odd values of n, you get minus. For even values of n, you get plus. And another thing that you must know is that cos of 2n pi, you will come across very frequently that this is equal to 1 for all values of n. So what is that I am teaching you now in this? Sin n pi is equal to 0 for odd. Whatever be your n, sin n pi is equal to 0. Whereas cos n pi is equal to -1 to the power of n, and it will be equal to -1 if n is odd and is equal to +1 if n is even, and cos 2n pi is always equal to 1. Now keep this in your mind. Let me come to deciding the values of this. Now you see that this is sine. So when you put pi or 0, this is going to be 0. Don't worry about this. You will get this into your hand when you practice a lot and involve in the subject. And come to this, when you substitute pi or 0, this will also become 0. So you are left only with this what? This one, take this minus sign inside. So it will be 2x into, yes. See, this 1 by pi is outside. Take it from me. That 1 by pi, it is 2 by pi is outside. This 2 by pi is outside, so I am writing this. So you write this as 2 by pi within brackets 2x cos nx whole divided by n square, and it's 0 to pi. Now you see that for the first limit is you apply x is equal to pi. The second limit, if you put x is equal to 0, the whole thing will become 0. So there is no need to try that. So put only x is equal to pi, you will get this is 2 by pi into 2 pi into cos of n pi. So this will be equal to, it is 4, 2 into 2, 4. So is this 2 pi into 2 pi, 2 by pi into 2 pi, it is 4 into, so here you have got here n squared is at the bottom, and as I told you, cos n pi is equal to -1 to the power of n divided by n square. So this is equal to -1 to 4 -1 to the power of n divided by n squared. So this is what you will get. So you see that your an value has been got. So your an is equal to 4 into -1 to the power of n divided by n square. So I have got all these values. So you see that I have got all the values, that is the Fourier coefficients. Substitute them in this one, you will get the Fourier series. Now I'll write everything now. Therefore the Fourier series is given by, therefore I'll rub off everything because we don't need this. So this Fourier series is, therefore Fourier series of f of x is equal to x squared is, x squared is equal to, your f of x is equal to x squared is equal to a naught by 2 plus sigma of 1 to infinity of an cos nx plus 0, because the other one is bn is 0, is equal to, I will write here itself. So this will be, what is your a naught now? A naught is half of 2 by 3, half of 2 by 3 into pi square, into 2 by 3 into pi square plus This is sigma of 4 into minus 1 to the power of n squared into cos nx. So this is equal to 1 by 3 into pi squared plus sigma of 1 to infinity of 4, you can take it outside, minus 1 to the power of n divided by n squared into cos nx. So this is your answer. So this is the Fourier series for the function f of x is equal to x squared defined in this particular area. Now here you are asked to prove this result. Hence prove this result. See, this result cannot be, you cannot deduce from this. You have to use Parsevel's theorem. Parsevel's from, if you apply, that is, if you use that Parsevel's theorem, you will be able to get this result. So let me now tell you what is that. Say, I will prove the Parsevel's theorem in a separate class, but I will tell you what is that Parsevel's theorem. I will write that Parsevel's theorem, apply that Parsevel's theorem for this problem and see whether this particular result could be got. So I will do that. Okay. Now, so this is my Fourier series. Now let me write this. See. So the Fourier series has been got. Now that I will write the Parsevel's theorem states that, I will write here the Parsevel's theorem. States that is equal to x is defined in plus minus. Length of the interval is equal to so this is your length of the interval. See, this is your length of. So this is actually speaking, this is the square root of this divided by 2 pi is called the square mean square root, and let me not talk about that here. Let me concentrate only on this Parsevel's theorem here. So what does the Parsevel's theorem state? So it states that it is minus pi to plus pi, because we have taken the Fourier series in the interval minus pi to plus pi. So it is minus pi to plus pi f of x, here it is dx, and this is equal to, I will write it here. See, I will write it here because you must understand correctly. That is why take every pain to see that it is minus pi to plus pi f of x modulus of that divided by 2 pi is equal to this. So this is what. Now you see that, let me write this as, so this implies minus pi to plus pi f of x okay, this is what we get here. It is equal to So here it is sigma of an squared only because your bn is equal to 0. That is, so this is equal to 2 pi into, now substitute the values of this. See, here you have got a naught, so it is 2 by 3 into pi squared whole square divided by 4 plus half into, see here 16 into minus 1 to the power of n whole square divided by n to the power of 4. Now you see that this is the one, you have to square this an square. An square will be 16 minus 1 to the power of 2n divided by n to the power of 4. That is 16 by n square. See, this is nothing but minus 1 whole square whole to the power of n. Minus 1 whole square is 1. So this is nothing but your 1 to the power of n. So that is nothing but what? 16 by n square. So this is nothing but your 16 by n square. So this is equal to, so this is 1 to infinity. So if you go for this simplification, (4 by 9) pi to the power of 4 plus half into sigma 1 to infinity 16 by n square. So this is what you get. So this is, now we have to do manipulations and see that we are getting this answer. So I'll rewrite here now. So that is, so I'll write this. So here you see that 2 pi is there. So it is equal to 2 pi. Here you get 2 by 9. 2 goes off. It is 2 by 9 pi to the power of 4 plus 16 by 2 1 to infinity of, see, this sigma of 1 to infinity 1 by n to the power of 4 I am getting here. You just see that. Now I have to do some manipulations and get the answer. Now, so this is what you get. Now this is an odd function. This is this one, no, it is minus pi to plus pi x to the power of 4x, because f of x is equal to x square. So f of x whole squared is power 4. So this is an even function. So it is so this is what you get. So your left edge. Now LHS. LHS. Now what is that you will get here now? Therefore equate the left hand side equal to right hand side, then you will get the answer. So what is that you get? It is equal to 2 pi into 2 by 9 pi to the power of 4 plus 18 1 to infinity. Now you see that this 2 and 2 will go off, so you are left with what? Pi by 4 5 2 by 9 pi to the power of 4 plus 8 1 to infinity 1 by n to the power of 4. This implies, what is that you will do? 8 into 1 to infinity of is equal to pi by 4 pi n to pi to the power of 4 divided by 5 minus 2 by 9 pi to the power of 4. So how much will we get here? 9 pi by 4. So you will get here, see how much will you get here now? So this one you will get that to be a naught by 4. A naught by 4 will be, just see whether you are getting a naught by 4 will be equal to your 2 by 3 4. See here I made a mistake. See here it is not it is it is a naught by 4 will be equal to 1 by 4 into a naught square. A naught squared by 4 will be 4 by 9 pi to the power of 4. A small correction is there. So in this place, in this, say I have written here, a naught squared by 4 will be equal to 1 by 4 into your a naught is 2 by 3. So 4 by 9 pi to the power of 4. So you see that this and this will go off, giving you 1 by 9 to the power of 4. So a small correction you make. So here a small correction. It is 1. Here it is 1. Here it is. So here it is 1. So a small mistake has come in the subtraction, addition, subtraction. Here you see that a naught squared, I will substitute. So in this place, what is the Parsevel's theorem? Parsevel's theorem is, your Parsevel's theorem is this. Your Parsevel's theorem, I will write here, Parsevel's theorem is minus pi to plus pi f of x whole squared this divided by 2 pi is equal to a naught squared divided by 4 plus half into 1 to infinity of an squared plus bn squared. So in this place what happened was a naught squared means what? It is 1 by 4 into a naught squared is 4 by 9 into pi to the power of 4. So this a and a will go off, giving you what? 1 by 9 into the pi. So this 1 by 9 a pi to the power of 4. So this is a correction. So a small correction I am making here. So you see that you are getting this 1 by 9 into pi to the power of 4 pi 4. So what is that you will get here now? So therefore you get this pi to the power of, that is, this is equal to pi to the power of 4 by 5 minus pi to the power of 4. So this is equal to, so I will write here. So I will write here. Therefore here you have got 8 into sigma of 1 to infinity 1 by this is equal to pi to the power of 4 minus pi to the power of 4 by 9. So this is equal to, how much do you get here now? So you get this to be, it is 9 minus 5 is 4 pi to the power of 4 divided by 45. This is 45. So this implies one to infinity of so this will go 2 times So I have arrived at the answer. So you see that what is that I have done here? I have applied the Parsevel's identity theorem. That Parsevel theorem, it states that this one minus pi to plus pi f of x modulus square divided by dx 2 pi is equal to a naught by 4 plus half of sigma of 1 to infinity a n squared plus b n squared. I substitute here b n happens to be 0. Substitute the values of a naught and this one. So you will find that in this place a small mistake has come. Here it is 1 by 9, not 2 by 9. So you see that you replace that by 1 by 9, then you do all simplifications. You will arrive at the answer that 1 to infinity of sigma of 1 by n to the power of 4 is equal to pi by 4 divided by 90. So this is my answer. So this is here in this class I have taught you about what is Parsevel's theorem, application of Parsevel's theorem, and I have taught about your odd and even functions and how the an, bn, what will happen to the Fourier coefficients if f of x, the given function, happens to be even, or if it is an odd function, what will happen? If it is an odd function, you will have only bn. If it is an even function, you will have a naught and an. So I have used that idea and I have done this problem. So this is a important problem from the university point of view because there is application of Parsevel's theorem. Concentrate this on this. I will do more problems in the coming days. Thank you.